All right, so today we're going to be talking about finding slope from a graph. So this should be a pretty, simple-ish concept. But again, just to refresh ourselves, when we talk about slope is always equal to the rise over the run, or the y over the x, the change in y over the change in x. That's basically what slope is when we talk about our slope of a line. Now, when we are looking at a graph, and this assignment's nice because it basically gives us the 2 points already. If we look closely, we can see 2 points. But basically what we're looking for is we're looking for 2 spots on our line where it's hitting an intersection on our grid. Okay, that'll give us nice even numbers. If we look at 2 points that are not on intersections, we're going to get uneven numbers. And basically what we do to figure out the slope is we figure out those 2 points. So I see a point right here and a point right here, and we're going to build a stair to go up the ramp. Okay? So I just built a stair connecting those 2 points. And now once I built that, to figure out my slope, all I'm going to do is I'm going to figure out the rise, that's what's happening up and down, and put that over the run, what's happening left to right. So here it's going up 1, 2, 3, 4, 5, 6, and over 2, 1, 2. So that would be a slope of 6 over 2. Now the issue here is our slope, we always want our slope in its most simplified form. So can I simplify 6 over 2? Well, yes, 6 over 2 would simplify to 3 over 1, right? Or just 3. But you can write it as 3 over 1 because slope is generally expressed as a fraction. So either way it would be correct, either just 3 or 3 over 1, because 3 as a fraction is just 3 over 1. Okay, let's look at another example. So if I look right here, again, I'm looking for 2 points on my line where it's crossing or hitting the intersection on the grid. And again, this worksheet already has the points, so I kind of know exactly where it is hitting. But again, you want 2 points where it's hitting the intersection on the grid. And then again, you're just going to build the stair, this time to go down the ramp, okay? But it's the same idea. You figure out the rise, and you're going to put it over the run. So the rise is technically going down, right? So 1, 2, 3, 4, 5, 6, 7. So it's 7. I'll come back to that. And then 1, 2, 3, 4. So over 4. Now, there's something wrong with this, right? Because this is going down, that shouldn't be just a positive number, right? Positive means it should be going up, right? So because this is going down, this is actually negative slope, so that's 7. I mean, technically, as long as one of these numbers needs to be negative, but since we went down, I'm just going to make that a negative 7 over 4. Just as long as one of them there. You can put the negative in front of the fraction too, that's fine. Just the negative goes to one of those numbers. Either of them would be fine, because if you think about it, you could be going right 4, which is positive, down 7, which is negative, or you could be going up 7, positive, left 4, which would be negative. So one of them could be negative, one of them positive. That's how negative slopes work. So again, just to do another example of that, this is another negative slope, and it's time for students to leave the building, I guess.
You need to exit the building. Have a good day.
Sorry about that. And then again, I got those 2 points. I'm just going to build the stair, and it's going over 1 and then down 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, 6. Yeah. So down 6 over 1, that'd be a negative 6 over 1, or just negative 6. Okay? But we do have some special slopes as well. So when it is a flat slope here, so right here, I see a flat slope. It's flat, there's no slope at all. So if I was to figure out my rise, it's not going up at all, right? So that would just be 0. It's going over, if I do these 2 points, it'd be 1, 2, 3, 4. That'd be like 0 over 4, right? But if I take 0 and divide it by 4, what's 0 divided by 4? 0. So, and that makes sense, right? There's no slope here. It's a flat line. When we think of flat lines, we don't think of having any kind of slope at all, right? Because there is no slope. It's just a flat line. So this would be a 0 slope. There's no slope there. Okay, so anytime you get that flat line, that would be a 0 slope. There is also the vertical lines. So if I look at a vertical line, and it's hard to see, so I'm going to darken it. This is the vertical line right here. So that's the vertical line. So if I look at like the rise, like just any 2 points, so figure that would be like 3, right? So it's going up by 3, but what's the run? It's not going left or right at all, so the run would be 0. Well, what happens when we try to take any number and divide it by 0? So 3 divided by 0, oh, I get an error. It's not actually possible, right? I can't divide things by nothing. It's just not possible. That doesn't make sense, right? I can't divide it by nothing. That's not dividing it. That's just leaving it, because if I divide it by 1, I'm just leaving it alone, right? Dividing it by nothing is impossible. You can't do it. So this is what we call an undefined slope. Because you can't actually do it, the run is 0. This is undefined. It is not possible. And that's all you're doing basically when you're finding the slope from a graph.